In this video, we're going to discuss how to factor special cases. Special cases are going to involve perfect squares and perfect cubes. We're going to start with difference of squares. In order to understand how to do these problems, make sure that you can recognize all of the perfect squares. Those would be numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. You have to be able to recognize all those numbers as a perfect square in order to know to use this method. Alright, so in the first one, looks like I've got a typo here. Now, example 1, we're going to do x squared minus 36. And we're going to use the difference of squares formula. Anytime you're subtracting two perfect squares, it always breaks down as basically the square root of the first term minus the square root of the second term, and then the square root of the first term plus the square root of the second term. So the first step is to determine what do A and B represent. A is whatever I have to square to give me my first term. So if my first term is x squared, then A is x. B is whatever I can square to give me my 36. So that would be 6. Once I've determined A and B, they go straight into my formula. So my answer is going to be x minus 6 times, and then A plus B, that's going to be x plus 6. And that's it. Example 2, I'm going to factor y squared minus 9 25ths. Okay, so yes, you do have a fraction, but if you notice, both the numerator and the denominator are perfect squares, a 9 and a 25. So the square root of 9 over 25, all you do is take the square root of the top over the square root of the bottom. Square root of 9 is 3, square root of 25 is 5. So we'll use the fraction 3/5. So this tells me that B for the formula is 3/5. And A for my formula is the square root of my first term, so A is y. So just put it into my formula. I need A minus B, so that's going to be y minus 3/5 times A plus B is y plus 3/5. And that's my answer. Number 3. We need to factor 3x squared minus 75. The first thing I notice here is that 3 is not a perfect square. 75 is not a perfect square. Okay, but if you recall, we always, anytime we're asked to factor, we always start by looking for a GCF, and this does have a GCF of 3. So let's pull the 3 out. That leaves x squared minus 25. Okay, 25 was on my list. It is a perfect square. So now I can say that A is what do I square to give you my first term? A would be x, B is 5, because 5 squared is 25. So to factor this, I bring down that GCF, and then I've got x minus 5 times x plus 5. Number 4. I've got x to the 4th minus 81. 81 is a perfect square. It's 9 times 9. X to the 4th, because it has an even exponent, it's also a perfect square. X to the 4th is equal x squared times x squared. Okay, if you recall, when you multiply like bases, the rule is to add the exponents. So that tells me that my A this time is x squared, my B is 9. So I can apply my formula. A minus B is x squared minus 9. A plus B is x squared plus 9. Okay, can we do any more to this? X squared and 9, these are both perfect squares. All right, in the first set of parentheses, they're being subtracted. In the second set, they're being added. Now, where they're being added, this is not a special case. There's nothing that I can do here. X squared plus 9 is prime. But the difference with the subtraction can be factored some more. So this time I can say that my A is x and my B is 3, because that's what I need to square to give me my terms there, x squared and 9. And then I can break that down. I can say it's going to be x minus 3 times x plus 3. And then the x squared plus 9, it needs to come down and join it. So my answer is x minus 3, x plus 3 times x squared plus 9. So that's how the difference of squares works. If you have a sum of squares, that is, you can always, unless it's got a GCF, you can always say that your sum of squares is prime. So for example, if you had, let's say 25x squared plus 36, because this is a perfect square and this is a perfect square and there is no common factor between the two, that one is just prime. The sum of squares is always prime. All right. And then the next situation is going to be a sum of cubes or a difference of cubes. And this time you need to make sure that you can recognize perfect cubes up to 10 cubed. So let's make a list of that. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. The 7, 8, and 9, I don't know if you're going to need those, and honestly, I don't even remember what they are myself. 7 cubed, 8 cubed, 9 cubed, I don't know if you're going to have to know those. I'll get back to you on that. But 1000 is 10 cubed. So if you see any of these numbers, you should recognize these as a perfect cube, and that's going to tell you how you need to proceed with your factoring problem. So with that in mind, let's look at my first example, x cubed minus 1. All right, we've got these formulas. All right, so they probably look like a lot because they have a binomial like the last one did, but then it's followed by a trinomial. If you look at the formulas, however, look at them carefully, you'll see a pattern. The first set of parentheses is just the original a cubed plus b cubed, but without the exponent. So if it started out with a plus, it's going to have a plus here. And over here with the difference of cubes, it started out with a minus and it's got a minus here. So that part's easy. The trinomial piece is always going to be a squared, ab, b squared. Okay? Same, both of them. A squared, ab, b squared. So you can remember that. And then for the signs, we've got this little way to help us remember it. It's going to be same, opposite, always positive. Or you can say SOAP. Same, opposite, always positive. So same just means that whatever sign that the original problem had is going to be the same in the first set of parentheses. So we started out with a plus, we got a plus. Started out with a minus, we got a minus. The next sign is going to be the opposite. It's going to change signs in front of the AB in both of them. So it went from positive to negative, negative to positive. And then the last term is always positive. So we're going to do a little table to help us keep it straight, and then we're going to practice several of them until we get the hang of it. So in our first example, we're going to factor x cubed minus 1. Okay, so first thing I notice is I've got this 3 as an exponent, so that's a perfect cube. 1 is also a perfect cube. So I'm going to fill in this table here. I'm going to do a, b, a squared, ab, b squared. And as I fill that in, so a is x, b is 1, because that's just doing the cube root of the first term is x, cube root of the second term is 1. What is a squared? Well, that would be x times x, so x squared. What is a times b? X times 1 is 1x. What is b squared? It's going to be 1 times 1, which is 1. Once you've got this filled in, you just remember same, opposite, always positive. So we're going to say x, because it was originally subtraction, we'll say minus 1. And then it's going to be x squared. Now it's going to be opposite sign. And then AB is x. And I'm sorry, that should be x squared. And then the last one is always positive, so plus b squared. And that's it. Example 2. Okay, that was an ambulance that just came by. All right, so second example, we're going to do our table. So AB, A square, AB, B square. So A is what I cubed to give me my first term. A is X. B is what I cubed to give me my second term. That's Y. A square is X square. AB is X times Y. B square is Y square. And then I go to my set up the answer. It's going to be X. It's going to be same sign that I started out with, plus Y times X squared, opposite sign, XY, and always positive, and then Y squared. The nice thing about these, though, is once you apply your formula, you're done. You don't have to do any guessing, checking, or any other steps. Okay? Example 3. We're going to do A, B, A square, AB, B square. So A, this time, you got to do the cube root of the 27 and the cube root of the variable. So the cube root of 27 is 3, so A is 3x. B is y. What is a square? Well, that's going to use square the 3 and square the x, so it's 9x squared. AB is 3xy. B squared is y squared. And then you can put it into the, you can do your answer. 3x is a, same as the original, so minus b is y. A squared is 9x squared. You're going to do opposite sign. AB is 3xy. Always positive. B squared is y squared. And that's it. These are not hard once you get the hang of them. All right, number 4. We need AB, A squared, AB, B squared. Okay. A is the cube root of 125x cubed. So that's going to be 5x. B is the cube root of 8a cubed. Cube root of 8 is 2, so it's 2a. A squared means you're going to square the 5 and the x, so that's 25x squared. AB is 5x times 2a, so 10xa. Or I want to say ax, 10ax. B squared is going to be 2a times itself, so 4a squared. Now we can give our answer. So a plus b is 5x plus 2a, so it's the same sign as the original. Then a squared is 25x squared. Opposite sign, AB is 10ax, and always positive, so plus B squared is 4a squared. My answer is 5x plus 2a times 25x squared minus 10ax plus 4a squared. And I guess that's it. All right, that's how you handle special cases.